Okay, here we are, 2-4 day 2. You might hate me today, but that's okay, because I am going to give you some super shortcuts for the mean, variance, and standard deviation that you just learned to do that long way. So the super shortcuts for mean, variance, and standard deviation. There's nice programs built into our calculator for this, and we'll get to those in a second. You first have to get used to the notation, because the programs use the symbols to represent these. So you've seen population variance and population standard deviation, and the sample ones, but I did not give you the symbols for population mean, is lowercase Greek letter mu. Population variance you have seen is lowercase sigma squared. And then you know the connection to standard deviation is to take the square root of that. So that brings you down to a symbol for population standard deviation to be just sigma. Okay. Now for samples, if you're not dealing with every single member in the population, you've got a sample. We have symbols for all three corresponding ones here. So the sample mean symbol is x bar. But remember, when you're finding an average, there's no difference in the formulas. You just add up your data values and then divide by how many you have. So the calculation, each of these would be the same. But you know between population variance and sample variance, there is a difference in the formula, in that we divide by one less here than we do over here. So it's the same 6 steps, just that that 6th step is different. So the sample variance, remember, is s squared. And then to get the standard deviation, we take the square root of that. And that brings us down to a sample standard deviation symbol of just s. Okay, now where are these programs at? All of this stuff and more is calculated under one little program in the calculator. So here's what you first have to do. You first enter your data values into a list. And then pay attention to the list number. And then on the calculator, you're going to go to, I'll write it down, then I'll do it. You're going to go to Stat, and then over to Calc. So I will show you that right now. Turn this on. Our normal Stat button, where we do Stat Edit. Get this up here. Stat. So I press Stat, and across the top, you'll see Calculate and then Test. We'll be using this in another chapter, but we're going to go over to Calculate. And the first one is 1var stats. That's the only one we're going to be using here, one variable statistics. So you will select the first program, number 1, which is 1var stats. And then when you do that, it wants a list number. The default is list 1. So if your stuff is in list 1, you don't even have to put list 1 here. But if you've got stuff in list 2 or list 3 or list 4, you got to give it that list. And let me see what I've got in here just for funsies. Stat, edit. Okay. Oh yeah, this is our first example. I'm all set. I'm going to do list 2, and that's going to give me all kinds of information about these numbers that I have in list 2 here. So list 2. Okay, 1var stats generates all kinds of really useful information, and I'm going to go right down the list. Okay, the first symbol you see on here, I'm trying to get it right here, is x bar. X bar is giving you the average of that list, the mean. then you'll see sigma x. Well, you know sigma means to add up, and then x, it's just saying I'm going to add up all of the x values. It's going to sum up the numbers in my list. So that second one is the sum of your x's. The next symbol you see is sigma x squared. So what that's going to do is square every number and add them up. So it's the sum of the x squared. Then you see, this is an s, that's sx. Well, if you look above, and then you see the sigma x. So s and sigma, very important, because if you look at our symbols we had above, s and sigma are our standard deviations. Okay? So the calculator is calculating both of these because the calculator doesn't know whether I put in a population or whether I put in a sample. It just knows I put in 5 numbers. It can't read my textbook and know what it's referring to. So it calculates sample standard deviation and population standard deviation. I've got to know which one of these to pick. And we'll come back to that. So, and you know there's a difference in calculating these. That's why it's giving you 2 different values, which you just learned the long way. So the Sx is our sample standard deviation, which we will be using. And then sigma x is our population standard deviation. We'll be using that one also. Okay, next thing is n equals 5. That's telling me how many data values were in the list. So that's the number of data values. And you can see there's an arrow down. There's still more information built into this 1-bar stat. So if I arrow down, next one's the minimum value. So it's the minimum x value. Pretty straightforward there. Arrow down. Q1, that's a quartile. We're going to be talking about those in the next section. So I'm just going to put Q1. I'm going to call it quartile 1. Even though you don't know what that is, you will learn about that tomorrow or in the next section. Median. So that's our middle value. And then keep going. Q3, that's called quartile 3. Out of room. Again, that's for tomorrow. Keep going. There's still an arrow. We got a max x value, self-explanatory, the highest value in my list. And then that's the end of it. So there's all kinds of information. But if you look, we've been calculating variances along with standard deviations, and notice it did not give us the variance. It only gave us standard deviation. So we have to know the connection from standard deviation to get variance, and if the book asks for variance. And we just know that all I've got to do is square this to get back to variance. So it doesn't give you variance, and I think the reason is because standard deviation is the one that's used most often, because variance has those squared units that typically aren't applicable to anything in the real world most often. So there's our super shortcuts, and now we're going to use them. Our first example is to compare 2 golfers. So we've got golfer A and golfer B going out for the first time this year, and here's their first five scores for 9 holes. So golfer A shot a 45, a 47, a 40, a 42, and a 45. Golfer B shot 67, 66, 67, 65, 66. Okay, I would like you to find, or be able to find, the mean variance in standard deviation for each of these golfers. And these are going to be population data sets. These are considered populations because it is all of their scores for this season. So these are populations. So I would like golfer A's mean score, variance, and standard deviation. And notice my notation is matching population values. Same thing for B. And we're going to use the super shortcuts. Okay, I already took the time to put them in. You can see I've got golfer A in list 1, golfer B in list 2. So if I go back, I go to Stat, over to Calc, 1var Stat. I can type in list 1 or not because it's the default. So X bar is my mu because there is no difference in calculating an average. It doesn't matter whether it's a population or a sample, I do the same thing. So his average is 43.8 strokes for 9 holes. Variance is not on here, so I got to leave that blank, but I do want the population standard deviation, which is the sigma on here, so about 2.48. And then for me to do variance, I have to know that the connection is that I've got to square the variance, or square the standard deviation to calculate the variance. 2.48 squared, about 6.15 strokes squared. Strokes and strokes. Okay, do the same thing for golfer B, and then I'm going to ask you some thinking questions. So I'm going to go back to Stat, over to Calc. I want to calculate 1var Stats again, but this time I want the scores that are in list 2. His average is 66.2. His standard deviation is 0.75. These are strokes. Strokes. And then for variance, I've got to square that. 0.7483 squared. Just being a little more accurate, about 0.56. And remember, what this number is telling me, the standard deviation is how spread out. The smaller the number, the closer the values are together. So I can see this guy has much more variance in his scores than the golfer B. So my first question, who is the better golfer? My second question, who is more consistent? Well, I don't think we really needed any statistics to answer the first one. We can see this person over here has got way lower scores than this one over here. And the average does back that up. So golfer A is the better golfer because he's got a lower average. A, lower average. More consistent, remember, more consistent would mean they do the same thing all the time. There's not a big variation. And that would be golfer B because his standard deviation is lower. So B, lower standard deviation. Okay, so that's our super shortcuts. You'll be able to use that on your quiz to at least check your answers, even though you got to do it the long way. Continuing on with variance. Oh, yes, I'm going to switch papers here. Right here. We still have to do standard deviation and variance for grouped data. So it's kind of a part 2. Standard deviation and variance for grouped data. Okay. So, take a look at an example. They went through a neighborhood and did a sample of homes. And they were counting the number of kids per household. So they went knocking on a sample of homes and were asking how many kids lived in the house. and their study had homes that had anywhere from no kids up to 6 kids. And they made a frequency distribution. So 10 of the homes they went to had no kids. 19 homes had 1. 7 homes had 2. 7 had 3 kids. 2 homes had 4. 1 home had 5, and 4 homes had 6 kids. My question here is to ask you to find the mean, the variance, and standard deviation for the number of kids per household. What's the average number of kids per household in this neighborhood? So, because we're dealing with sample, get the symbols, start practicing. The mean is x bar. Variance will be s squared. And standard deviation will be s. Now, we're going to use super shortcut, but if we were to do this by hand, remember, I would be averaging up not just 0 through 6, because I've got 10 of these, 19 of these, 1 of these. Technically, if you add this up, they went to 50 homes. I've got to average up 50 values. So we would be having 10 zeros, 19 ones, 7 2s, and we could do that the long way by putting 50 numbers in a list, 10 zeros in a row, 19 ones in a row, and calculating it that way. But there's a quicker way to deal with this. Okay, the quicker way to do it is to use your 1-bar stats. Now you can tell it, because the programmers built it this way, if you give it 2 lists, it assumes the first list you put in are your x values. So in this case, if these are in list 1, then you put a comma, you put in a second list, it automatically assumes that that second list is your frequency. So you need your data values separated by your frequency. And the calculator will do all of that work for us and give us everything we need. So I did put these in a calculator, one of these calculators already, not that one. They're in this one, not that one. So much for me trying to save us time. There we go. So there's my kids in the house, my frequencies. So I'm going to quit. I'm going to go to Stats, Calc, 1-bar stats. Oh, depending on what operating system you have, it may not look like this, or it might look like this. But your list is where your x values are at, list 1. Your frequency list for me is list 2. So I already did this, I believe. And then I calculate. The older ones, this doesn't come up. You have to separate with a comma. And it did it for us. So the mean number of kids per household is 1.82 kids per house. The standard deviation I want, remember there's the S and the sigma, this was a sample, I want this. So 1.72 kids per house. And then for me to get the variance, I've got to square that value. If I quit, 1.72 squared, 2.93 kids squared per house squared. And again, you can see how useless those units are. But again, all we're really looking at is the size of the number to tell us how spread out things are. Alright, so that's how you can deal with group data fairly quickly. And then one other way to get group data is with that frequency distribution, which is somewhere. Where did that go? Oh, here it is. Okay, number 3. If I've got a frequency distribution where I use a range of numbers here, we've got monthly income for a sample of, I don't know where this is in the city, but it's monthly income. Oh, I think this was college students. For a sample, again, you got to know whether you're working with a sample or a population. That's got to be given to you. For a sample, college students. Okay. So, they broke it up this way. Not a traditional frequency distribution, because you're going to see these ranges aren't all the same, but we had no income. 33 of the students they talked to had no income. $1 to $99, 4 people. 100 to $199. You can see they got a $100 class width here. It's $100 or $99 class width. Or that one's 99, this one's 100. Yeah, it's from the 0, yep. So we got 4, now we got 10. And then 200 to $299 for 13. 300 to $399, 12. 400 to $499, 11. And then kids making over 500 or more, they had 17. Okay, so for us to do this, again, this one's easy. We do actually have 33 zeros. Here's 4, somewhere between 1 and 99. Again, this will be an estimate for us. So our best estimate for all of these is to use the midpoint. So the only difference I wanted to show you between what we did here, we weren't given a range, we were given the actual values. Here we've lost our actual values and now it's grouped. So our best way to do this is to use the midpoints. Except for this one doesn't have a midpoint, we're going to use 0. 1 and 99, we've got 50. 150. 250. 350. 450. And the 500 and above, you get to pick. You could actually look at those numbers and use the average of them, but since we don't know it, I'm going to just continue this, go up by 100 and go with 550. And this, our answers will be estimates. And again, we want mean, variance, and standard deviation. These are samples. So again, the calculators are built to do this. Our quick way, use the 1-bar stats. And we want to use the midpoints, comma, frequency. So I've got those. Not that one. Right here. So I've got the 0, 50, 150 all the way down. So I've got list 1 and list 2 is my frequencies. So I'll quit. Stat, calc, 1-bar stats. Okay, this one's got the older operating system. So now I do have to put in the L1, comma. Remember the comma? I don't know if you remember or not. The comma's right above the 7. And then L2. Kind of glad this one didn't have that same operating system. And now I just hit enter. And there's all that information again. So, mean is $234.5 per month. And I want the sample standard deviation, 210.54 dollars per month. And then we would square that number to get the variance. So 210.54 squared dollars squared per month squared. And I'm not going to take time to actually square that. Okay, so there's your super shortcut. Just 2 more little things to do in here without a calculator. right here. So number 4, can you give me a rough estimate of the mean and standard deviation here? First one's pretty easy. I'm going to give you a graph of a frequency distribution. Data values are 5, and I have 10 of them. So maybe I interview 10 people and see how many fingers they have on one hand. Well, all 10 people I talked to had 5 fingers on each hand. So if I asked you for the average, I'd be averaging up 10 5s. Well, obviously that's going to be 5. My standard deviation is how spread out. What's the average distance away from the mean? Well, if they're all 5s, they're all equal to the mean. So here, the standard deviation would be 0. And those would be exact. All right, try another. Let's say, same question. How many fingers are on one hand? I get 5 people that happen to only have 4 fingers on one hand. And I get 5 people that happen to have 6 fingers on one hand. So I've got 5 4s and 5 6s. If you think logically, what's the average of 5 4s and 5 6s going to be at? Well, that average is going to be right smack dab in the middle, 5 fingers. And nobody actually has 5 fingers on the hand. Standard deviation? How far away from the mean are these? Well, these are 1 away, they're all 1 below, and these are all 1 above. Standard deviation is going to be 1. So again, these ones will be exact. This next one's going to be an estimate. Alright, let's go. 2s, 3s, 4s, 5s, 6, 7, oh, 6, okay. Let's go with, I've got 2 2s, 3 3s, 3 5s, and 2 6s. So very symmetrical here. So that's 10 values, and I want to know what's the average. Well, the average, again, is going to be right in the middle. Because if you're adding 5s and 3s, you get 8s. If you add 6 and 2s, you get 8s. If you take all your 8s and divide by how many you have, you're going to end up with this. We've got 10 values here. We're going to get that average of 4 in the middle. So the average is going to be 4, right down the middle. Okay, now for standard deviation, well, think about it. The 3s and 5s are 1 away, but then the 2s and 6s are 2 away. And with standard deviation means I'm going to average those distances away. So I've got 1 away and 2 away. So that means when I average 1s and 2s together, I'm going to get a number somewhere between 1 and 2. So for the estimate here, that's all I want you to be able to tell me is that, oh yeah, it's going to be between 1 and 2. So over 1 less than 2. And because I've got more 1 aways than I do 2 aways, it's going to be closer to the 1 than it is the 2. So really you could tell me it's going to be under 1.5. But this is fine for you. Just give me a rough estimate of what standard deviation is. It's the average distance away. Okay, last one. Number 5. Can you write a data set, make a data set, that has 10 values with a mean equal to 9 and a standard deviation equal to 3. So I want the average of my numbers to be 9, but I want the standard deviation to be 3. I want them all 3 away. Well, this graph right here is the one that's going to help you figure that out. Take a look. They're 1 away, and I wanted the average to be 5. So the 5 is in the middle, and you go 1 away. Well, here, I want the average to be 9, but I want my values to be 3 away. So all you've got to do is go 3 below 9 and 3 above 9 and give me 5 of each of those. So that would be, if I do it number line, 3 above, 1, 10, 11, 12. And then 3 below would be at 6s. I would want 5 6s and 5 12s. So my data set would be 6, 6, 6, 6, 6, and 12, 12, 12, 12, 12. That's the easiest one, is to go exactly 3 away from your numbers, above and below, equal amount. That will make your average come out and your standard deviation come out.